Okay, this video is going to introduce something called the logarithm. It sounds confusing, and it may look confusing at first, but it's actually no different than using an exponent. So if you have an equation like 4 to the second power equals 16, right? This is true because 4 times 4 is 16. This is called an exponential equation. It has an exponent in it. What I'm going to show you is a way of writing the exact same equation using something called a log, or a logarithm. Like I said, it's just another way of saying the same thing. We're not changing the values of any of this stuff. We're just writing it in a different way. Here's how you would write this as a log equation. Log, which stands for logarithm, base 4, and I got that 4 from this base here, right? The base of our exponential term. Log base 4 of 16. The 16 is written normal size. That's what we're taking the log of, equals 2. What used to be the exponent is now all by itself on the right side of the equation. So these two statements that are now on the slide are equivalent statements. They're saying the same thing. 4 to the second power equals 16 is the same as saying log base 4 of 16 equals 2. They're both true statements. The only difference here is the way it's written. The second equation, the one with the log in it, can be very helpful if you're ever trying to get the exponent by itself. So what used to be stuck to the 4 is now all by itself on the other side of the equation, that 2. The way you would read this, it's important that you see it written out. You heard me say it, but I'll write it down. Is log base 4 of 16 equals 2. Okay? On the next slide, we're just going to practice converting from one form to the other. All of these are equations written in logarithmic form, and I want us to rewrite them in exponent form. All right? We're not changing anything, we're just rewriting it in exponent form. So when you look at letter A, if you read it to yourself in your head, it says log base 2 of 8 equals 3. The fact that it's log base 2 tells you something very important, that 2 is the base of your exponent. And you'll remember me saying on the previous slide that these are helpful because they get the exponent by itself. Well, what is by itself in this equation? It's the 3, which means the 3 was our original exponent. And 2 to the third power equals what's called the argument, the 8. Okay? Let's try it on letter B. Log base 4 of 1 equals 0. Base 4 tells us that 4 is the base. The exponent is the number by itself on the right side of the equation. And sure enough, anything to the 0 power equals that argument, which is 1. In letter C, we have log base 12. 12 is our base. Our exponent is the number that was by itself in the log equation. And 12 to the 1 power equals 12. For the final one, and fractions are very common here, so get used to seeing them. We have log base 1/4. All right, let's write that as our base. Notice I put it in parentheses. My exponent's going to go outside of it. The exponent is the number that was by itself, so the -1. And we know what a negative exponent means. It means to flip your answer, and it stays positive. So when we flip a 1/4 and leave it positive, equals 4, which was our original argument. Okay, so this is how you take a logarithmic equation and rewrite it as an exponential equation. These are asking you to actually evaluate it. Okay, so what this is basically it's the same. I'm going to switch back a slide so you can see it. It's the same thing as this, only you're not given this part of the equation. What does it equal? What does it equal? What does it equal? That's what you're asked to find here. What does it equal? How do we evaluate it? Okay, what I want to do then is write equals question mark. And I'm going to use a question mark instead of a variable here, because it's not actually an equation. They're not asking you to solve the equation. They're just asking you to find the value of that. So I like to set it up as if it's an equation, okay, equals question mark, which means that log base 4, well, 4 is my base. My exponent, I don't know here. That's what you're trying to figure out. It says equals question mark. I don't know the exponent yet. And it equals the argument, which is a 64. So you have to ask yourself, 4 to the what power is equal to 64? You should be able to do these without a calculator. I'm going to try to use nice numbers that you can do mentally. If you need a calculator, use it to do some guess and check for now. We'll practice more in class without it. So 4 to the question mark is equal to 64. By now you should know that this question mark must be 3. 4 to the third power is 64. Okay? So the value of this log is equal to 3. We just write our answer as a single number because it was asking us for the value of the log. Okay? For this second one here, letter B, our base is 5, our exponent is the question mark, and it has to come out to 0.2. Well, this is just cruel. The textbook is being evil by giving you something like 0.2. You might want to take out a calculator and convert that to a fraction. 0.2 as a fraction is the fraction 1/5. Okay? Fractions are so much easier to deal with. I always say that. Here's a perfect example of why. If it said equals 0.2, I would have no idea. 5 to the what power equals 0.2. But I do have some idea of 5 to the what power equals 1/5. Well, how do I turn a 5 into a 1/5? I'm going to have to flip it. How do I flip something? With a negative exponent. So the value of that question mark right there must have been -1. That's how I ended up flipping a 5 and it becoming a 1/5. In letter C, we have log base 1/5. So our base is a 1/5. Our exponent's a question mark. That's going to come out to 125. So somehow I'm going to have to flip that 1/5 so that the 5 comes up top, and then do some exponent so that it equals 125. Well, you might have recognized by now that 5 times 5 times 5 is 125. But how can we get that 5 to be up on top? We're going to have to make that exponent negative. So it's going to be a negative, and the third power, because 5 times 5 times 5 is 125. And then the last one, running out of room here, 36 is my base, and the question mark is my exponent, and it has to come out to equal 6. So 36 to some power equals 6. And you're probably looking at that and thinking, well, it's a square root, right? But you can't write square root as your exponent. So you have to remember that square rooting something is the same as saying to the 1/2 power. Okay, so the value of each of those logs is the exponent that's missing from the exponential equation. There are two special types of logarithms, and these are the types that you can use your calculator to help you with. All right, so you should be happy now we're getting to the calculator part. One of them is called the common logarithm, and that's a log that has a base of 10. If you take out your calculator, you will see a button on it that says log, all right? But just typing in log 5 is a shorthand for saying log base 10 of 5. The log that is on your calculator is assuming that you mean base 10. Obviously, we can have a log with other bases. Every other slide on this presentation has had other bases than 10. But the one on your calculator is assuming that you mean base 10. So when you have an equation later on in this chapter, and I'm asking you to find this, you can't just take out your calculator and type log 5. This is not a log base 10. Your calculator is not going to help you with this, right? I'll teach you ways later on to solve this type of problem, but right now, you can only use your calculator if you see this as the problem, log 5, or if they actually show you the base is 10. Right? If they don't show you a base at all, you can assume that the base is 10. And you can use your calculator to get it. Similarly, when you have log base e, and e is that number we started recently learning, right? It's that constant that shows up a lot in math. You have log base e, they shorthand that and they call it ln of x. ln is just a type of a log. It's called the natural log. I don't know why they don't call it NL for natural log. They call it ln instead. And ln is another one that you're going to be able to figure out on your calculator. So if I ask you to find ln of 5, you are able to just type that in. It already knows that you mean base e, and that's built into the calculator. Okay? So on the last section where it says evaluate the logarithm, use the calculator if necessary. Well, you'll notice that the first one is a log base 2. I just told you you can't use your calculator unless it's base 10 or a natural log. Well, this one's not base 10, it's not a natural log, so this is a clue that I'm going to have to do this one in my head. I am looking for the value of the question mark, right? 2 to the something power equals 32. By now I know that 2 times 2 times 2 times 2 times 2 is 32, which means my exponent, my value of the log, would be 5. Number 6, I have another base that is not 10, and it's not a natural log. I can't use my calculator. I set up the exponential equation, 27 to the question mark equals 3. So somehow I need to get from a 27 to a 3. Well, if you're thinking like I'm thinking, that's a cubed root, right? That's a third root. But I'm looking for an exponential form. So to say a cubed root is the same as saying 1/3 power. So that's the value of that log. And finally, I get to this number 7 up here. This is a log base 10 because it doesn't show you the base. And that means you can assume it's base 10, which means you can take out your calculator, hit the log button, and put in a 12. When you hit the log button, it's going to open up a parentheses for you, log parentheses, and you just type the 12 right into it. In fact, you don't even need to close the parentheses. It'll do that for you. When you write your answer, I want you to round it to the nearest hundredth. So you'll say this is approximately 1.08. And the last one, we have a natural log. Again, you can use your calculator for this. Find the button that says ln. It's going to open up the parentheses. And in that parentheses, you put 0.75. Hit enter. And the calculator will tell you that this is approximately, rounded to the nearest hundredth, -0.29. And that is all.